This is Spare Time Repair, and this is a Makita site radio that I looked at in a previous video. If you haven't seen that video, you might want to check it out before you watch this. But in summary, it had no power, and I eventually traced that to a blown fuse on the main board, which I temporarily jumpered with a piece of wire just to check that was the problem. Then I had to order some new fuses, which have now arrived. But it also had another problem, which was that the power button was not doing anything. So as soon as you connect power, the radio comes on, but then you can't turn it off again. So in this video, I'm going to replace the temporary fix I did with the piece of wire, because I now have my fuses from China. And I'm also going to look into the power button issue, see if we can solve that as well. I skipped the teardown because I did that in the previous video, but this is my jumper wire where the fuse used to be. And these are my new fuses. They're not as small as the one that came out, but I couldn't get the exact one. I mean, they're still pretty tiny. I had to order 10 of them. So at least I've got some spares if things go wrong. So first, let's remove our jumper wire. Okay, that was simple. Now I'm just going to tin the pads up ready for the new fuse. Don't you hate it in these videos where someone has the component in exactly the right place and then they go and move it? I think that's okay. I think I just tried to touch both pads at the same time. No. Okay, that may have got it. It looks ugly as hell, but it might have worked. I can test it by probing this pin, which I know is linked. Actually, both these are, as I marked previously. We are getting through. So we know that's going to restore power to our radio. We've already proved that. The issue is why this power button is not having any effect. Thing is, I don't know how I'm going to be able to test this without reassembling and disassembling multiple times. Because these boards are connected by pins rather than ribbon cables, I can't test it when it's apart. Well, maybe I can. I can take this board out of the front, loosely reassemble. And I don't have to connect everything like the antennas or anything like that. Okay, let's have a go. Here is the power button. We know that it works. It's these two that are relevant because these two are isolated. So where does this go? So that switch contact feeds all the way around here, through this bridge, into here and into this, which is labelled M7. Is that what's responsible for latching the switch? So it looks like it's a bipolar transistor. And what's happening is that we have no connection to the collector of that until I press the switch. And it then feeds through this little network of resistors. There's a capacitor in there as well. It looks like it then feeds into this chip. This resistor is labelled 334, which should be 330,000? 212,000. I'm becoming more convinced that it's something to do with this M7 component. One of the poles on the switch goes straight through to the collector, and the other one goes to this leg here. And obviously when you touch the switch, it connects them together. So if this were a transistor, that would be what latches the switch. So our M7 component is a bipolar transistor, and blah 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 makes the device capable of amplification or switching. So that would seem to fit. My prime suspects are this M7 transistor and this 330k resistor that's only measuring 200k. I don't keep any spare components. All I've got is this donor board. It's an old PC motherboard, but I've been over the entire thing and I can't find either an M7 or a suitable resistor. So it looks like I'm going to have to order them. Okay, a week has now passed. My new resistors have arrived and I had to get 100 of them. Annoying. So I was about to start replacing it and I thought I'll just double check that reading. And now it's giving me 320, which is basically what it should be. So I don't think there's anything wrong with that resistor. I can try it with this meter as well. I swear a minute ago off camera that was giving me 320 like the other meter was. I don't know, but the long and short of it is I don't think there's anything wrong with that resistor. It was a complete waste of time and money to get these. I mean, does anyone want 100 resistors? I can do you a good deal. But that was always a long shot. I think the M7 is a much more likely candidate. So I was looking up how to test a bipolar resistor. So if you put one probe on the base, which should be this leg here, so getting about 1 meg there, and about the same there. So if we swap, put the black lead on the base, see, I thought we should get nothing. So I don't know whether that means it's bad or I'm just not testing it correctly. See, now that resistor's reading 220 again. So it's only reading correctly when I have my leads this way around. Swap them over. Okay, for various reasons it's been a couple of weeks since I recorded that last segment, so I'm just trying to get up to speed in my head as to where I was. I think I decided not to replace this resistor because it was reading okay in one direction, but I'm still confused as to why it appears to have a polarity. Like, even if another component was dragging it down, I don't understand why when connecting the probes directly to it, it wouldn't read normally. So I think I might remove it and test it out of circuit just to eliminate that. The new resistors, so that's absolutely spot on. And of course, it's the same in both directions because resistors don't have polarity. So I'm going to do that just for the sake of it. This transistor I'm still curious about. So another development is that I've bought myself a component tester. So I think I'm going to remove that also, hook it up to the tester and see what it's saying. There it is. Right, 327. If I swap my probes, it's the same. Of course it's the same. I thought you could measure a resistor in circuit. I thought that was never a variable. I mean, call me an idiot, but that's just what I thought. But clearly it does make a difference. So we have got about 8 megaohms between those pads. And in the other direction, 1.5 meg. I thought if your probes were on the resistor itself, then regardless of how the other components are interacting with it, you were going to get the reading of the resistor. We absolutely know now that changing this resistor isn't gonna solve the problem. It's not going to make any difference, but I'm going to do it anyway. I did get the wrong size, so I hope it fits. No, it's too big. So I'm going to try putting the old one back on. It's wonky, but I think it's on there. Oh, okay, well that's good news. I'm pretty sure those legs are all making good contact. Damn it. I was hoping it would not read as a transistor. That looks okay, doesn't it? Right, I managed to solder it back on. I did it off camera because I had to really lean over and I would have blocked the camera anyway. The long and short of it is I'm back to square one, although I have eliminated a couple of possibilities. Retracing my steps a bit, these two pads are the ones that are shorted together when you press the power button. Okay, they both feed into that M7 transistor. This one is the leg on the right, and this one is the bottom left. But this also feeds in to this thing here and all these little components. So maybe one of these is faulty. I'm thinking that maybe I should reassemble, power it up, and see if any of these get hot. Maybe one of them's shorted. But of course the problem is that if I power it up, I need to fit this board on top here, and then I've got no access to those components. Something else I've noticed, we've got 3 Zener diodes here. They all look the same, but they're not measuring the same. This one is open in this direction, and is 1.77 mega ohms in this direction. This one is basically the same, open. And when I swap the leads, about 1.7 meg. This one, which is in the area of our suspected problem, that's 230k. Sorry, you can't see the scale. 230 kilo ohms. And in the other direction, similar. That seems wrong to me. Firstly, being a diode, you'd expect it to not have a reading in one direction. So when we go into diode mode on the meter, 0.6 volts. And in the other direction, 2.9 volts. And the other ones, open and 0.6 volts. And this is the other one. I know you can't see me doing it. 0.6 and open. So these two on the left are behaving identically, but this one is not. This one is different. I don't have any Zener diodes, or do I? Let's see if I can find one on another board. Well, what do you know? On the old PC motherboard, there are 3 of them. Oh, this one is 1.4 meg. and open in that direction. Right, the one on the left is from the old motherboard. The one on the right is obviously from the radio. So let's go to ohms again. So the motherboard one, right, 1.6 mega ohms. I'm going to swap the leads. It's open. So this should be open if it's the same. Ah, damn it, I think it is. 1.7 meg. There's nothing wrong with it, is there? Just to double check that, I've got it hooked up now to the tester. Okay, Zener diodes, 507 millivolts. Sorry, 517 millivolts. Okay, and now the other one. Yep, Zener diode, 506 millivolts. So they're basically reading the same. Okay, last throw of the dice. I've noticed that there are a number of L7 transistors on the back here. In fact, there are 11 of them. There's 4 here, 1 here, 5, 6, 7, 8, 9, 10, and 1 here in our area of interest. So 11. And when I turn over, we have 4, 9, 10, 11 buttons. So maybe they're the things that are registering the status of the button. If I replace this one, if I swap this out for one of the other ones, maybe that'll make a difference. Like if our power button starts working and one of the other buttons is no longer working, then at least we'll know what's causing the problem. If I swap it for a button that's less important, I don't know, this is a big stretch, but I'm going to give it a go. Right, I've just tested the suspected faulty L7, but it's come up with this, which seems okay. I mean, this is definitely a long shot. I've now taken another L7 off the board. Okay, test this one. Hopefully I've hooked it up okay. Yeah, that's registering the same. This is probably a wild goose chase, but I'm going to swap them over anyway. Then I think I've got no choice but to put the whole thing back together and see where we are. Okay, those are swapped over. I don't think there's anything else I can reasonably do. So let's put it back together. Now, if you watched the previous video, you'll know that I didn't have a Makita battery to test it with. And also I didn't have the original power transformer, so I had a bit of trouble rigging up something to power it. So I thought I'd order a universal power supply, which comes with a range of different tips. And on top of that, I ordered a few more. And you would think that with all these different possibilities, you'd be covered for any eventuality, wouldn't you? None of these fit the radio. None of them. So I'm still in a position where I have to rig something up, but it will be slightly easier than last time because now I've got this adapter where I can connect wires directly to it, and so I'm not sort of using electrical tape or anything, but I just couldn't believe that none of these were compatible with it. Right, I've cut a short piece of electrical flex. I've tinned the ends. So these two will go to the crocodile clips, and I'll connect these into the socket. Just going to wrap a piece of tape around one of these to ensure there's no short. I've ensured the polarity is correct. And this goes up to 24 volts, so it's dial it up to 18. It's a bit hard to get it accurate, but I think that's close enough. No, that's made no difference. Just been doing a bit more tracing, and one of the legs of this M7 transistor takes us to here. That bridges across here, and that feeds around through these 0 ohm resistors to this capacitor. So I tested this capacitor and it looks dodgy. Here's my ESR meter, and it's tricky to do this with one finger, but when I probe it, it says it's open. And so then I probed it with the multifunction tester. Now it's giving me this reading, but earlier it said the ESR was over 8 ohms, which feels very high, too high. So I think I'm going to remove this from the board, test it out of circuit and see what we get. Let's see if I can hook that up to the meter. 68 microfarad, ESR of 8.6 ohms. I'm saying that's not correct. Problem I have is that I don't know what it should be. I've got no schematic for this. So do I just put a random capacitor in and hope for the best? Okay, well, no, I don't know. That's a contender, I suppose. I'm going to put it on. What have I got to lose? Well, I mean, it's easier said than done. I'm going to have to do it off camera, I think, because I'm going to lean into the shot. Well, it's wonky, but it's on there. So I'm going to reassemble and see if it's made any difference. No, that made no difference. As soon as I connected it, the power came on and the power button still does nothing. Well, after spending an absurd amount of time on this, I've given up and cheated. What I've ended up doing is cutting into the main power line here that feeds into the board. I've got 2 wires coming off that and feeding a toggle switch that I've mounted on the side of the case. It's not ideal, it pokes out a bit, but it's the only one I had. So I drilled a hole through the case, tightened that on, and that is now the on-off control. So it's not a fix, it's a workaround, a modification, if you like, but it should work. I'll just put it all back together and then show it to you. So here we are, we're all connected back up to the power, and if we switch our switch on, we have action. So yeah, I feel a bit disappointed that it came to that. Like I say, it's a bit of a cheat, but you know, it restores functionality, and frankly, I've just had enough of this thing. I've spent countless hours on it. I could have kept trying to replace components, but you know, life's too short. So yeah, I hope you're not too disappointed with that result, and hopefully see you in the next one.